Hi folks, welcome to week 2 where we're going to talk about categorical data and we're going to do a little bit more coding in R. Like last week, I have a pre-lab for you and then I have the real lab for you. And what I'm going to walk through in this video is the pre-lab. So last week I had the files already loaded up on Rstudio Cloud for you, but this week you have to upload them yourself. So if you go to my Canvas announcement and click on the pre-lab document, it should say something like, you want to open this or save it. I'm on a Mac, so yours might look a little different. And I'm going to say, just save it, and it's going to get saved into my downloads folder. Depending on the kind of computer you have, it might try to put a .txt at the end of the file name. So it might say stat220 categorical variables prelab formula.rmd.txt. And that's going to make Rstudio Cloud confused. So you should rename that file so that it just ends with .rmd. You can do that by usually kind of like right-clicking on the name of the file in your downloads folder or wherever it went. So we've done the first step of downloading the document, and then the second thing we need to do is to upload the document to Rstudio Cloud. So you can click this link to get into my Rstudio Cloud space, and it's going to show you the project that you have. So there'll be two things in here, and I think it doesn't actually matter which one you click on. I would click on the one that's associated with your name. So not the one that says continue, but just the one that says labs derived from labs by me. I have a student account, so that's what this means. And then when I get in here, this will look just the way that it looked at the end of last week when I logged out of Rstudio Cloud the last time. So that's one of the things that's really amazing about Rstudio Cloud is it saves everything and it's just where you left off. So even if you haven't saved a file, it should have the most recent thing that you were working on. So you can see I've got my describing data pre-lab still open. I've got some code that's already been run in here. The first thing I'm going to do is close last week's pre-lab and close my little data set preview. And then I'm going to go over here. It looks like I'm already in project pre-labs. So this is the folder where I'd suggest you put the pre-lab. If I was in project and I needed to get into the pre-labs, I could click on the link to get into that folder. So I'm going to click upload, and then I'm going to browse and try and find that pre-lab file that I downloaded onto my computer. And then I'm going to just say OK, and now it's got the file that I'm going to upload and click this. And now I've got two things here. I've got the describing data prelab and I've got the categorical variables prelab. And I could click to open it up like this. And now I'm actually going to switch to the desktop version of Rstudio. This works just the same as Rstudio Cloud, but I've found that I can zoom in on the desktop version a little bit, so it's easier for you to see what I'm doing with my code. But everything should work just the same. If you see anything that's different, feel free to ask me a question. So we're going to do our categorical variables pre-lab, and we're doing the formula version. In this course, we use 3 packages: the Lock5 data package, the Mosaic package, and the GG formula package. And last week, we learned how to use the library function to load them in. So I would encourage you to pause the video for a second and just make sure that you remember how to do that to put in the other 2 packages you need. Now I'm going to do it. So I'm going to type library parentheses mosaic, and then I'm going to hit enter outside my parentheses, and then I'm going to type again library parentheses GG formula. And then I can click the green play button here to get that code to run. Something might scroll by, or maybe it won't if you have already loaded your packages in your session. You probably have if you're working on Rstudio Cloud. So now we're going to go down to the loading in data section. And again, we learned last week how to read in a data set. You already have it in your environment, but in order for it to be accessible to R when you're knitting your document, you need to make sure that you have the data loading code in your R Markdown document. So see if you can remember how to do the data loading code. Okay, and I'm going to do that. So I'm going to type GSS, and then I'm going to use the assignment operator. So that's like a less than sign and a little dash. And I put spaces around my assignment operator. You don't actually have to. R is not picky about spaces, but it is picky about capitalization. So then we're going to use the function read.csv, read.csv, parentheses, and that should all be lowercase. And then inside the parentheses, we need quotation marks. So we do quotation marks. And then I was saying last week, I think the easiest way to get your file path is to hit tab. You should be able to see the data folder and hit tab. And then inside that data folder, you should have gssclean.csv, and you can hit tab again. If you don't see those things when you hit tab, it might mean that you uploaded your pre-lab into the wrong folder or not into a folder at all. You still should be able to use the tab key to move around and eventually find the file path, but it might not look exactly like mine. So that's why I recommend you put the pre-labs in the pre-labs folder and the real labs in the real labs folder. So again, I could click the play button here, and then the data would get loaded in. Again, you might have already had this data loaded into your local R session from our last lab, but you really need to get the code in here in order for your document to knit. If you want to, you can just try knitting right now to make sure that everything is working okay. And then you'll get a pop-up, something like this, which will show you what your lab looks like so far. It's looking good, so I'm gonna close out of here. So in this lab, we're talking about categorical variables. Those are variables that describe a set of categories rather than something that's numeric. So an example might be the variable is your class year, and the categories are first year, sophomore, junior, and senior. There's only those 4 possibilities. Maybe we've got super senior or something in there, but it's not like a number where it could be anything and have some decimals. There's only those 4 possibilities. So one question would be what variables in my example data set are categorical and how you can tell. And we looked at this, I think, last week, where we thought some categorical variables were things like college major 1, college major 2, diploma, GED, or other. So we're going to do what's called exploratory data analysis, and we're going to focus on categorical variables this week. We'll do quantitative variables next week. And when you do exploratory data analysis, there are 2 main parts. There's visualization, and then there's summary statistics. So we're going to do both of those, and we're going to start with data visualization. So like you probably learned in lecture, there are a couple ways to visualize categorical data. One is to use a bar chart, and another is to use a pie chart. So statisticians get kind of snooty about pie charts, and so it's kind of hard to make them in R because statisticians think that most of the time you should actually make a bar chart, and they've made it much easier to make a bar chart in R than a pie chart. So that's what we're going to focus on in this lab. And we're going to use graphics from the formula syntax. So remember, you're in the formula lab, and we're going to use functions that start with GF underscore. I'm pretty sure that the GF stands for graphics formula, and then after the underscore, we're going to have the name of the plot we want to make. So we're making a bar chart. The function we want is GF bar, and it's going to take a formula as its first argument. So if you haven't programmed before, probably both those terms are unfamiliar to you. And even if you've programmed before, you might not have heard what a formula is. It's kind of particular to R. So an argument is something that you put inside the parentheses of a function. So if you were in algebra class and you were talking about the function f of x, we would say the function is f and the argument is x. It's the thing that you kind of put into the function. So in this case, our function is called GF bar, and we're going to give it a formula as an argument. It's going to be the thing that goes inside the parentheses. Formulas are this idea in R, and it's just a way of writing code. It's a particular kind of syntax, and it goes y tilde x. So y is your response variable, And then there's this tilde, which on my keyboard is right underneath the escape key. It's a little squiggly line. It also has the back tick on that same key. It's above the tab. So underneath escape and above tab, your keyboard might be laid out a little bit differently. So we've got y tilde x, and x is our explanatory variable or variables. So if you just have one variable, you're not going to give the formula a y, and instead you're just going to do tilde and then your x variable. So I'm going to show you what this looks like in R. So I'm going to type it in my console. I'm going to type gf_bar, parentheses, and then a tilde. And I actually need to hit the shift key to get the tilde to work. So shift and then that tilde key. And then I'm going to write the name of the x variable that I'm interested in. In this case, it's marital_status, comma, data equals GSS. And then I'm going to get a bar chart of people's marital status. So one thing that you might notice is that my plots show up in the plots window rather than directly in my R Markdown document. That's because I have my options set a little bit differently. I think that it's nice because then I can zoom the image and we can look at it bigger together. So something like this. If you'd like to know how to change your options, just let me know and I'll tell you. But let's look at this bar chart. So it looks like most people in the data set are married, almost 1,000 people. And then we've got slightly fewer, but another common category is never married, divorced, widowed, and separated. So this is a visualization of one categorical variable. So you really need to get that syntax exactly right, otherwise R is not going to work. R is really picky about things like capitalization, but it's not super picky about things like spaces. So I like a space after my comma and around my equal signs, but the code would work just as well if you took those spaces out. What I'd like you to do is try making your own bar chart of the variable labor force status, pause the video, and then come back once you've got it done. Okay, I'm going to do it now. So I'm going to delete this comment where it says write code here, and I'm going to type gf_bar, parentheses, and then a tilde, and then I'll write labor_force_status, comma, data equals GSS. And then I could click the play button here. So let's look at this graphic. I'm going to pop it out so that we can look at it much bigger because some of these category names are really long. Okay, it looks like most people in the data set are working full-time. That makes sense to me as well. We've also got some retired people, people who keep house and are working part-time, and some other categories. So then the next thing we might want to do is do data visualization for two categorical variables. So we can make a bar chart that shows the relationship between two variables, and we're just going to add another argument to our gf_bar function. So let's look at this line of code here. So we've got gf_bar, and inside the parentheses, we've got tilde marital status, comma, here's some new code, comma, data equals GSS. So we always need to put commas in between arguments for our functions. If I took out that comma and tried to run this code, I would get an error. So that's one of the things to look for. If you get an error is, do I have commas everywhere that I need them? So the thing that we're adding here is a fill argument, and I want to fill by the variable born in US. But I need to tell R that it's a variable inside that GSS dataset. And the way that I do that is with the tilde, making it a formula. So let's click the play button and look at this bar chart. So this looks like the one a couple plots ago where we were looking at the distribution of people's marital status, but it's now colored by another variable, whether or not someone was born in the United States. And what we can see is of the 1,000 people who are married in our data set, maybe 800 of them were born in the US, and then the other 200 were not. So there's a smaller proportion not born in the US, and those proportions look the same across all the categories. There just aren't as many people in the United States who are immigrants. We could also make this bar chart a side-by-side bar chart by adding another argument to our function. So right now this is a stacked bar chart because those bars are stacked up, but we could make it a side-by-side bar chart by saying that we want to dodge the bars, sort of get them to dodge each other off to the side. So I'm going to add a couple line breaks to this code so it's a little easier to read. I like to put my line breaks after a comma. So I'll put my cursor here and hit enter. And Rstudio is automatically going to sort of line the code up so that it's showing us all the stuff that's inside these parentheses. I'm also going to go after the comma for the fill and after the comma for the data equals. So now I have this function, gf bar. This part is the same. This part we just added in the last step. This part is the same. And then we have one more new argument where we're saying position equals, in quotes, dodge. So let's hit the play button on that code. And now we can see basically the same information, but it's just laid out a little differently. So again, we can see that most people are married. More than 800 of the married people were born in the US, and a little less than 200 were not born in the US. And we can see the counts for the other categories as well. So what I'd like you to do is try to make a bar chart that shows the relationship between the variables government or private employee and self-emp or works for somebody. We could go look at the data set to see what those variables are like. It looks like self-emp or works for somebody has categories someone else or self-employed. And then government or private employee has categories private or government. So I'd encourage you to pause the video and see if you can figure out how to make this new bar chart. Okay, now I'm going to do it. And actually what I'm going to do is I'm going to copy this code from up here and I'm going to paste it in down here. So I'm going to delete out this comment and then paste in my old code, and then I'm just going to modify it. So instead of marital status, I'm going to write government or private employee. Instead of tilde born in the US, I'm going to do tilde self_emp or works for somebody. I'm going to leave the data as GSS so that R knows what data set to look in, and I'm going to leave that position equal dodge. You wouldn't have to do that. And then click the play button. So let's look at this bar chart. So this shows me that most people work for private companies and a smaller number of people work for the government. But of the private employees, we've got a much larger percentage of self-employed people. So a small number of people claimed that they work for the government and are also self-employed. Not sure how that exactly works. Maybe they work for some kind of contractor or something like that, that is their own business. But it makes sense to me that there's more self-employed people in the private sector. And we could have flipped the order of these variables. You might have done that when you did your own code. So I'm going to move some of this code around. I'm going to cut this piece out and paste it down here. Get a comma there. And then I'm going to cut this piece out and paste it up here. And I need to make sure to get rid of, like I've got an extra comma here. So I'm going to get rid of that and make sure I've got this comma, this comma, this comma, and then that, and it's closed off by the parentheses. Okay, so hopefully this code will work. I run it, great. So again, now I can see most people say that they work for someone else. Of the people who say they work for someone else, most of them are private employees. We've got some government. In the self-employed category, mostly working for private companies, a few government, supposedly. So one of the things that people sometimes say when they get through a class in R with me is, all I learned to do in the class is to change the variable names and the dataset name in code. And while I do want you to get further than that in your understanding, I'd like it that by the end of the semester, you really have an idea of the consistency of the code. And if you see a new function, you kind of have an idea of how it's going to work. But I think that even if you just get to the point where you can change the names of variables and data sets in your code, that's a huge skill. And statistics is a lot about making a little bit of code work and then interpreting the results. So as long as you can do that, you're going to be really successful. And I still count that as learning R, even if you feel that all you've learned to do is change some of the variable names. That's still a valuable skill.